Good afternoon, everybody. Looks like we're ready to go. I'm getting the cue for let's get started talking about web application security stuff. I just want to thank everybody again for showing up. Thank you for Katie and the rest of the BlueHat staff for having me. It's always a lot of fun for me getting to interact with a whole lot of Microsoft security people, Microsoft developers, and sharing what I know, and also learning in return about what works and what doesn't work in web application security. Yesterday, during the Web Application Security Summit, I gave a talk called the Top 10 Web Hacking Techniques, and which is a presentation I have done every year for the last couple of years that illustrates some of the latest and greatest attack techniques that affect browsers, that affect web servers, and all sorts of things. But it's actually a look forward at what we think the bad guys might be using against our systems going forward. This presentation is a little different. This is a look more or less backwards at the problem as we know it to date. All the vulnerabilities in all the websites across the world. Who's vulnerable to what and how often, and learning from that knowledge on what policies, strategies, and technologies might help to move the bar forward. So for those that are not familiar with me and the work that I do, I'm founder and CTO of BlueHat Security. I've done nothing but invest myself for the last decade in web security of all kinds, browsers, web servers, proxies, and all sorts of things. I've been fortunate enough to work with some great people, write papers, travel the world, and all sorts of things, and write books. But this is all I do. This is web security is where I live and breathe. And this talk probably should be, unless it's really odd, should be really germane and important to all of you, because we all use web browsers. There's, last I heard, 2 billion people online, and I would hazard to say that just about every single one of those people use a web browser to access the internet. We will all shop. We will all bank, file taxes, interact socially with other people. I mean, there's basically nothing, very few things that we don't do online in the modern world. And increasing this modern way of life as we've built for ourselves is increasingly under threat. We have terms such as cyber war, whether you agree with it or not. These are nation-state sponsored adversaries that would like to do damage to our systems if they can. We have cyber criminals that are every day profiting from the weaknesses in the system, making a whole lot of money, and it is their way of life. This is how they make their living. And also we have another kind of threat, if you want to call it that, hacktivism, where other people with hacking-based skills are trying to get their message out there. And we like to track on the success rate how these guys are penetrating our systems. Who are they? What are their motives? And what's most important to me is how they're getting into the systems. What are they targeting? And it's a great follow-up to the talk that Adam Shostak just gave a moment ago on malware and how end users are actually infected with different viruses and the methods to do so. Because with this kind of knowledge, we can start putting our security resources in the right place at the right time. So I want to share with you a couple of background stats on the industry that I enjoy. The first one is the Verizon data breach incident report. For those interested, working or interested in information security, I think this is a must read. The Verizon DBIR team, this is the team that goes out and does incident response on compromises. Team goes out, figures out what happened, how bad was it, what the bad guys stole, where the bad guys were located, and everything about an incident. And it's biased towards retailers and payment industry, but it's a good data set from hundreds and hundreds of incidents and hundreds of breaches. And they aggregate all this data and they tell us a few things about what we're up against. And the first quote, this is the 2010 report quote that reflects 2009 data, and it says, the majority of breaches and almost all of the data stolen in 2009, 95% were perpetrated by remote organized criminal hacking groups, hacking servers and applications. This tells us three things. Web applications are the target, and they're stealing most of our data, and the criminals, as they see it, are organized crime groups, if you want to call it that. Now, this might be a snapshot in time, anomalous, and it might shift every year. So we have to read the next year's report, and the message is the same. The 2011 data breach report, reflecting 2010 data, says the number of web application breaches increased last year and made up nearly 40% of the overall attacks. Bad guys are targeting websites and web applications. Bottom line, and that's the trend. Now, all this data that we've learned, this was all before these guys. these are all these logos and all these companies, very important companies, share all one thing in common. In the last 12 months, each and every one of them has had their websites compromised in some way, shape, or form. Some by nation-state actors, some by organized criminal gangs, and some by hacktivists. The impact will range from just public embarrassment to multi-million-dollar losses. In the one case of Sony, nobody could escape the news. It was something like 20 different website breaches in the course of a few weeks, and Sony set aside $170 million for cleanup. So it's not a trivial amount of money. But these are, this stuff is still going on. It's still happening. It's every single day. And these are the things that I track. So I read all the news stories and all these things, and I like, try to figure out how to derive meaning, what people are saying about them. And I find a lot of the anecdotes, a lot of the lessons in the stories that I'm reading are not exactly right. So I want to dispel some of the misconceptions, at least which ones I think the misconceptions that need dispelling. First, each and every one of these breaches, each and every one could happen to any online business. I still hear it today that will never happen to us. Why would anybody want to hack us? Or maybe those guys are way more insecure because we take security seriously. And I hear all these things, but nothing about any of these breaches, nothing about any of these companies, nothing I've seen in the general populace makes anybody different than any of the guys that got breached. Everybody can be a victim similarly. Second, here's the problem. Exploitation of just one website vulnerability is enough. That's all the bad guy needs to compromise websites, to compromise data, to down the system, impact users, impact business, cause losses, and so on. Just one vulnerability. And this is troubling because, as we know, as there's developers in the audience, I'm sure, it's tough to get to 0 defects. And if the bad guy just needs one, they're going to win eventually. And I'll try to address this in the stats as I go forward. What we also want to know is, as I showed yesterday, there's tons of different attack techniques, tons of things that the bad guys could conceivably do, but they start to gravitate towards a few different types of attacks that actually work for them, at least currently. The first one is SQL injection. SQL injection is a very popular attack technique used to extract data from databases right through the web applications. It's pretty simple to do. I mean, there's classes for it, there's tools for it. It's very, very easy to extract data from the database right through the web application. The second one, and it's sort of similar in the way it's as compared to SQL injection, the way it's executed, but it's specific to PHP-based applications, and it's a way to get system-level access, execute commands on the servers. Again, using nothing more than the web browser. You can use a tool if you want, but right through the parameters on a website, and you start executing system commands to compromise the system and extract all of its data. Now, here's the thing. Both these attacks, what the bad guys want is data, for the most part. They want data. And so when they extract data, you would expect these two attacks. And then what they do next is when they grab the password files, whether they're encrypted or not, usually your passwords are not encrypted on these websites, they'll reuse the passwords across different sites to compromise other ones. They'll take the passwords from this system and try them against that system, and they'll compromise that site and leapfrog across. And it's highly, highly successful when they do this. When, for whatever reason, these three techniques don't work, they're more than capable, more than willing to set up denial of service attacks against their targets. I don't think there's anybody online that hasn't suffered some form of denial of a service attack. And the tools are getting easier, and they're extremely effective. Beyond all this stuff, any exploit will work, but then the bad guys will also lace their websites with malware. So even if the website isn't the intended target, the visitors of that website are. So they'll lace the website with malware, so you get the whole drive-by download situation, which Adam was addressing during his talk. Finally, the last part is none of these attack techniques can be defended against by buying more firewalls or implementing more SSL. I still have to explain this to higher level managers and CIOs and CEOs that all the firewalls that they bought, all cool, well and good, but they're not going to prevent against SQL injection. That's not what they're designed to do. And finally, none of these attack techniques should be considered sophisticated by any modern standard. They are not. SQL injection, it was first written about Christmas Day, 1998. This is not something we just figured out. There's nothing new about SQL injection that we learned that makes all these attacks possible. We know how this works. We know how to defend against it. So beware of the term sophisticated as a way to say, whoa, not our fault. What does make some of these breaches unique is the victim themselves, or at least the adversary, picking their targets. There's two kinds of victims in the world. There's the victim of opportunity, or the target of opportunity, and the target of choice. A lot of these guys, there was a target of choice, and the bad guys were relentless targeting these particular companies for whatever the reason. So, and that's the thing. Once you're picked a target, it only takes the bad guys a certain amount of time before you're compromised and you are a headline. And this relates. Last point here, this relates to number 3. Software, as we know, will always have bugs, and by extension, security vulnerabilities. And I got this great quote from Michael Howard. You guys probably are way more versed in this than I am. The software development lifecycle, the goal of it should be to reduce, not necessarily eliminate, the number of vulnerabilities introduced and the severity of those that remain. Now, you take number 3, just one vulnerability, and if you can't get down to 0, then this impacts you. This comes down to timing and window of opportunity and fix rates, and I'll address these. But when I explain this part of the presentation to a lot of organizations, large and small, they always go, well, we want to stand up a good website security program. Where do we begin? And my standard answer, that's what I'm in the business in, really, is to hack yourself first. The bad guys are going to do it. You might want to know what they know, or eventually will when they choose to target you. So over the last 10 years, I've been pounding on websites, hacking the largest websites in the world, and thousands of them. And over the last 5 years, I've captured all the data. So let me, Katie alluded to it in the introduction. Let me tell you a little bit about the services we provide just momentarily so you know where the data comes from. So BlueHat, we're in website vulnerability management. Our customers hire us to find the vulnerabilities in their websites and help them get them fixed. The service is subscription, so what that means is we're using automation, scanning technology, and a human process. We're constantly assessing the security of the same websites over and over again. So if they change code, introduce more vulnerabilities, we're always on top of it. So what that means is, in a long scheme of things, we know the security of these websites every single day, day in and day out, because we're always testing them in the exact same ways. So let me give you the size of the data set. 400 companies in the data set, from enterprises to Fortune 500, over 4,500 sites in the system, sites that I guarantee you guys use. They're payment providers, retailers, financial services, banking, insurance, the major websites. So the bias in the sampling here is these are the guys that care about website security. So bear in mind when you see the data. These are the ones that really care, and they're the early adopters. 600 million requests per month to find all these vulnerabilities, and we're getting up to about 10 terabytes of new data per week. So we have scalability concerns as far as data goes, so massive data quantities. So let me get to the actual data. The average annual amount of new serious vulnerabilities introduced per website per year. These are the numbers trended over time. So let me explain a couple of key points in here so we can get this in context. These are serious vulnerabilities, and that's just my asterisk term for you can exploit the system, hack the user, get access to sensitive data, down the system, anything bad. These are headline-making vulnerabilities. These are the ones that you really should fix. They will not allow you to be PCI compliant with these particular issues. These are the ones you want to fix. Secondly, and the reason we like to measure these vulnerabilities per website per year is this is not static piece of software. These are web applications, online running businesses. So as they're running, as they're developing code, they're driving business. So you want to measure their security over the lifetime, because just because you're secure on one day, let me give you a better example. Let's say there's 2 websites, and one website has, let's say, 5 vulnerabilities, but they're vulnerable all year, versus another website that has 100 vulnerabilities, but those only exist for a day. You probably want to use that one. That one the second one you might want to consider to be more secure than the former, because the bad guy just needs one. So in 2007, getting to the point here, the average website that we were looking at in 2007 had over 1,000 vulnerabilities in it, 1,000 different ways to get into the system. And let me share with you how do we count, because there's all different kinds of ways to cheat with the numbers. Let's say you're looking at a URL, login.asp, and there's 5 parameters in that URL, var1, var2, var3. If 3 of those 5 parameters are vulnerable to SQL injection, that's 3 vulnerabilities, not 5, and certainly not 1. So that's how we're counting these numbers, because we never know which parameter goes to which code path. So that's how we're counting here. So they're a little bit inflated, but just for the sake of discussion, that's how we're counting. So down from 1,000 to 2008, we saw a decrease to 800 average, and then in 2009, just under 500. 2010, things got drastically better at 230, and now finally, as 2011 comes to a close, it might end at 145, 150 or so. That's the number. So 150 or so different ways to get into a website in 2010. So roughly 10 vulnerabilities per month. So one is, at the very end, that's a heck of a lot of ways to compromise a website. But on the other end, it looks like we're making substantial progress over time. I'll go through a lot of stuff. Any questions so far? Okay.
Actually, yeah.
Yes, sir.
Does cross-site scripting count as a serious vulnerability?
Yes, except in extremely rare circumstances. Most of the time, most of the time it would fall in the critical category. It didn't always, but now that we've seen what it can do and people are used to it, but yeah. And we'll get to some of those in a second on what these things actually are. So overall volume. Now, overall averages don't tell you the whole story. Let's break them down by industry vertical. To be included as an industry vertical, I have to have at least 30 websites in that particular vertical and a certain number of customers to have a bubble. We do have government and energy clients and things like that, but not representative enough. So we see the overall average at 230. Now, if you notice here, banking, healthcare, and manufacturing websites do far better than the rest. We don't know exactly why this is the case. We're outcome-based metrics. We just hack websites. We don't know exactly what they did internally. We don't know if they trained all their developers, hired, fired, using web application firewalls, intrusion detection systems. We don't know. We just know what happens as the outcome. So the banking, healthcare, and manufacturing guys do pretty well. But notice the difference between banking and financial services. In the interface, the customers can actually select what industry they think they belong to. So if you're a bank, you say, I'm a bank. And if you're a financial services company that provides services to banks, and it might be the same type of website, you'll say we're financial services, but they're not strictly speaking a bank. But for all intents and purposes, a bank can have their own commercial checking, but so can a financial services company. But look at the difference between the two types of vulnerabilities. The service providers don't do as well as the enterprise themselves. These are the outsourced companies in the financial services area. Secondly, to note that between banking and, let's say, healthcare, government-regulated industries, they tend to do the best among the industry for whatever reason. Government regulation, for some, and they have reduced website vulnerability counts. Now, in the retail space, there's something called the Payment Card Industry Data Security Standard. Industry regulated, and they have amongst the worst record as far as number of vulnerabilities at 404. So if PCI is making a difference, it could very well be, but we're just not seeing it, at least in our data. One of the explanations that we've been getting for this between, let's say, the stark contrast between banking and retail is that the banking guys don't change their applications that often. They'll change them 2, 3, 4 times a year maybe. And while the retailers and the social networking guys, they're changing their code all the time, right? Once a week, twice a week, Mother's Day, holidays, and all those sorts of things. And so and they say, well, comparing this way is not fair because we're under different operational constraints. And all the thing we can say is, well, life's not fair. That's your business model, and this is what we're measuring. So going further just a little bit and trending this data over time, I wanted to see if different verticals are progressing year over year. So it's kind of a difficult way to visualize the data in this way, but it's the best I got. So if you look at the different industries and you work from the left to the right, you'll actually see overall decrease in the number of average vulnerabilities. There's some spikes, blips, and different things. But for the most part, average number of vulnerabilities on a vertical by vertical average are decreasing. So we're seeing progress, and I think that's pretty encouraging. Now, everybody has a top 10. Top 10 lists are littered all over InfoSec. So this is our top 10. The way to read this particular slide is if you look at the very left, the blue is information leakage. 64% of the sites we tested in 2010 had at least one instance of information leakage. This is when the website gives us too much information, such as internal IP addresses, software version numbers, to something significant like the database usernames and passwords when you view source on their website. Yes, this happens. Now, And so it's a major issue, and it just this year beat out, I'm talking by tenths of a percentage over the long-standing % cross-site scripting. I would hazard to say, I would probably speculate to say just about everyone in this room is familiar with cross-site scripting. 64% of the sites we tested in 2010 had at least one form of cross-site scripting, and we've seen the impact of this vulnerability grow over time. It used to be just alert boxes, and then it became phishing sites that showed up that were overlaid, phishing sites on the real websites as opposed to the fake ones, because you can get websites to run executable code. We've seen them taking over email accounts, stealing cookies from bank accounts. We've seen web worms on social networks, and multiple social networks, including MySpace, Facebook, Twitter, and others. And I'm missing a few in there. So the impact of cross-site scripting seems to be increasing every single year, and there's an increased focus on it. Then you have other ones like cross-site request forgery, and if you're not familiar with this one, type it into your favorite search engine and go read about it. This is the sleeping giant, if you will, in web security. And I'll tell you right now, that number is artificially low. While we can scan very proficiently for cross-site scripting, automated technology to find CSRF is woefully lacking, and we're incrementing slowly. And furthermore, a lot of entities don't want us to report this issue because they don't figure it's a vulnerability that they have to fix because it's an artifact in the way the web was designed, and maybe they have a point. So this 24% represents the worst of the worst, the most significant, and this number, if I had to actually guess, it's probably more like 80 or 90%. For those that, just to give you a slight tidbit of what cross-site request forgery is, it's a way to force a user to make a request that they didn't intend to make. Let's say you go to your web bank and you log in, do your banking, and then you leave, and you happen your way across my blog. You've closed all your banking tabs, right? But you are still technically logged in. Your session cookies are still live. I then force your browser to make a post request or a get request to that web bank to transfer money out of your account to me. Think about it from the banking website's perspective. It is your browser, it is you, properly authenticated, making a legitimate request, and it will carry it out. So every feature on every website is technically vulnerable to cross-site request forgery, just the impact of per feature is a little different. So should you be able to do that or not? So it's a very bad vulnerability out there. You have to actually fix it on a feature-by-feature basis. Then we have other ones like SQL injection down the list at 14%. Then you have information insufficient authorization at 15% in the red. Broadly speaking, about half of the top 10 are what we call technical or syntax vulnerabilities. You put a little injection in, you notice some kind of error message or behavior, and you spot a vuln, things you can automate. But the other half you really can't. If you're logging into a financial application and you see account ID equals 1,000, and you rotate it up or down by 1, and you jump into somebody else's bank account. You get some privilege escalation there. Scanners can make those requests, but they can't tell if it's good or bad. So there's a whole host of issues that we can't find with scanners yet. We call those business logic flaws or semantic vulnerabilities, and that's the other half of the top 10. They don't tend to be as voluminous in number as the syntax-based vulns like cross-site scripting, but they're every bit as damaging, and most of the time worse so. Let's cut it down by class. This is the top 7 by class. Because we want to see if different industries are suffering from different types of issues, and that doesn't seem to be the case. Everybody is suffering from the same types of flaws, just to different degrees for the most part. So you can kind of see on the bottom left there, the 43% of the banking applications that we tested in 2010 had at least one instance of cross-site scripting, versus on the far right, 75% of the telecoms had at least one instance of cross-site scripting. So same types of volumes, just different volumes. But the one that kind of stuck out to me, which is pretty interesting, because I'm always watchful of the vulnerabilities the bad guys are going after, and that's SQL injection. If you notice on the far left, the banking sector, it has no pinks, even though it drops off at 10. I had to go back and check out the data, and SQL injection is there, but it's actually more like 6.5–7%. So it fell off the top 10. So for reasons we can speculate on, the banking sector guys actually, for the most part, rid themselves of SQL injection, probably because the bad guys forced the issue. And that's also a trend that we see, is that vulnerabilities are not handled in terms of perceived severity. They're handled class by class. The organization, for whatever reason, say, we hate cross-site scripting, no more, and they'll go after that one versus all at the same time. So I've given you volume and I've given you type, but I want to start going into something a little bit different. I think the security posture of a website must take into account remediation rates and time to fix metrics, because, as I said before, websites are actual operating businesses. You don't get to say to the attacker, you only get to attack us on the first Monday of the month. They can go after you 24/7, so you have to measure the security 24/7. You take all those different metrics together, and I put something together called window of exposure, which is the number of days in a year a website is exposed to at least one serious vulnerability, something that will make them headline news, something that will cost them money, something that will compromise the system. And this was quite eye-opening for a lot of people, including myself. So if you look at the very top line, what that means is that 44% of the sites we tested in 2010 had at least one serious vulnerability every single day of 2010. It might not have been just cross-site scripting, it might have been a SQL injection, it might have been whatever the case may be, but every single day you fire up your browser, you go to the website, and you're going to find something serious on that day, every single day. If you include the sites in the orange, or that they were vulnerable 9 months or more, you have a total of 68% of sites that were vulnerable every single day or close to it. That's staggering. So while those broad averages are scary, they don't tell the whole story because not all verticals perform equally. If you go down to the bottom, you'll see the banking websites. 51% of banking websites in 2010 had a serious vulnerability less than 30 days of the year. So clearly the banking guys are doing something that nobody else is, because they're doing really well. And that's where I perform the most of my research internally, is I want to know what the guys in green are doing that the guys in red are not. And those are the lessons that we need to learn. What are they doing that's making them so secure? And it's got to be more than just pulling the plug on their website. Any questions so far? Okay. As part of our work, of course, we find vulnerabilities and we have to communicate that to our customers. And I should also keep in mind that these are not CVE-related vulnerabilities. They don't have CVE numbers. These are all one-off issues in custom web application software that our customers, developers write, or somebody wrote on their behalf. You know, vulnerability, a SQL injection vulnerability in Site 1 has nothing to do with in Site 2. So we find the vulnerability, we tell them what it is, where it is, what parameter, how to replicate it, how bad it is if it's exploited, and also how to fix it. It is then their responsibility to task a developer to fix it, code up the fix, QA it, and roll it to production where we can retest it. Between the found date and the fix time, we measure time to fix. And that's what you see on the horizontal in days. On the vertical, you see a cumulative website percentage. Just to start off, if we follow the black line up, which is the industry average, until it hits on the vertical, the 50% mark, and draw a line straight down on the time to days, what we find is that the average, historically, this is over years and years of data, when we find a serious vulnerability, it takes the average company 100 days to fix the issue. A little bit more than 3 months. Think about that for a second. A serious vulnerability that could be more or less catastrophic takes them 100 days to fix, or thereabouts. It is a little bit different in the banking sector. The banking sector, when you get to 50% mark in the red there and you draw a line down, you get to about 31 days or 32 days. So the industry average is 3 months, the banking average is a month. So something the banking guys are doing is working, that it's not working for the rest of the industry. Maybe they just care more. I mean, it's hard to say. Then you have other ones like the insurance guys, and they do below the bar. You only get a time to fix metric when vulnerabilities are actually fixed. Cannot tell you that all vulnerabilities are fixed, fast, or ever. And this is the remediation rates. Starting off at the later parts of 2007 all the way to just about the end of 2011, this is my data. If you follow the trend line, you'll actually see a slow increase over time in the percentage of vulnerabilities that we have found that have been fixed over time, going from about 4 to 5% per year annually. So again, not the steep rise that we'd like, but we are showing progress. There are more vulnerabilities are getting fixed over time. And it's resting at about 53%. So think about this. About half of the vulnerabilities we'll find will be fixed, and they'll be fixed in about 100 days. That's industry average. So these are useful metrics. Let's say you're standing up your website security program. You want to know, well, what's our policy for fixing vulnerabilities? Well, if you want to be above average, then you only have to beat 100 days. I mean, sounds easy, right? And you only have to fix half of them. Such a deal. So, as I mentioned, we run a subscription service, right? And what we found in our business is that those who remediate vulnerabilities have a higher likelihood of renewing their service because they don't want to spend money paying for last year's report. So we're highly incentivized to work with our customers to get as many of these issues fixed as possible. So we ask them, why don't you fix these? And we get a whole amazing amount of answers. The first one is, no one at the organization understands or is responsible for maintaining the code. Development group does not understand or respect the vulnerability. So yes, we have to describe what cross-site scripting is, what CSRF is, and SQL injection is every single day. There's 17 million developers in the world, so it takes time. Lack of budget to fix the issues. Any of these familiar? Effective code is owned by an unresponsive third-party vendor. The website will be decommissioned or replaced soon. And we've had those sites with that meta information in there for a year or more. The risk of exploitation is accepted. Clearly, we communicated something wrong. The solution conflicts with business use case. It's one of my favorites because it's a feature. Compliance does not require fixing the issue. That might explain the whole retail sector. And then one of the ones that I spend most of my time on, it's actually quite serious. Feature enhancements are prioritized ahead of security fixes. I find this to be one of the more fundamental challenges in software security. Because I have to put myself in our customer's shoes, is that they are banks and retailers. I mean, these are not software development shops. Their mission in life is not to develop software, it's to run a bank. But they have no shortage of software developers. So think about it from their perspective. These guys have to fix their own vulnerabilities. They don't get a patch from Microsoft or Oracle or anybody else and have IT patch it. They have to fix their own issue. So which means they have a very complicated choice. They have to, one, do they A, continue investing resources in creating revenue-generating features that if it doesn't ship, will cost them money? Or two, do they fix one of the vulnerabilities that we find that may get exploited, that may cost them money? And how do they come to that conclusion? And there's not very good data on this, on which answer is the right one from a business perspective. We do the best we can with it, but this is where a lot of the research is going, and how to make that determination is when you trade off features for security when development time is limited. It's extremely tough. What we did find is that testing speed and frequency matters a lot. And these are something that the developers in the audience will probably appreciate. Security guys, we're a little slow on the software stuff, but we're learning. So if we take, let's say, a standard SQL injection or a standard cross-site scripting flaw, and the developer writes a piece of vulnerable code, if we figure out a way to communicate the vulnerability in that code within a week of them writing it, we find it takes them less of 1 hour of labor to actually fix that issue. Because they are tasked on that piece of software, they're familiar with it, it's probably already up on the screen, and it's all there at the right time. If we wait, or if we get there late, or anything comes up, after 1 week and a month's time, that same vulnerability will take anywhere between 1 and 3 hours of work. 3 times the amount of work to fix that issue, because they probably have to be retasked, you have to get familiarize yourself with the code, and so on. So feasibly, you lost a day of productivity fixing that one vulnerability, that one same vulnerability. Or it gets even a larger contrast, and this is where 90% of the sites we're deployed upon, is that the developer who wrote the code is long gone. Anything from a year or more when you communicate that knowledge back requires 2 to 3 days or so, or 10 hours of labor. And a lot of times the person who has to fix the code is not the person who wrote the code, because they have to find the code, reestablish, the build systems and get the code in, whatever their IDE is. So it takes a lot of work fixing codes later, just for logistic reasons. So testing speed and frequency matters. So, thus far I've shown you that, where bad guys target, the money that they're gaining, and I've shared with you all the vulnerabilities that we're finding in websites. Yet we're faced with this fundamental question. If we know so much, why do breaches keep happening? And why do they continue to happen? If I ask the audience here, how do you fix cross-site scripting? You might tell me some form of input validation or output filtering on your data. If I asked you about SQL injection, you might give me the input validation or parameterized SQL statements. If I asked you how to securely store passwords, you'd probably say the hashing compare model. Each and every one of these vulnerabilities I've shown you, there are solutions for these. We're not, it's not like we don't know how to fix any of these ones. We know how to fix every single one of them. We have a little bit of an issue with a resource allocation. So I cannot seem to think that the answers to our problems, the reason why these problems keep happening has anything to do with the technical challenges. I think it has to do with policy and resource allocation. So to illustrate this, I want to play what I call the IT budget game. Now, let's say you were to go to CFO at a company, Microsoft included, maybe you guys are the anomaly, or maybe not, and you ask the CFO to take their gigantic IT budget, the money you build IT assets with to build the business, and you ask them to separate the budget dollars into 3 buckets. Applications, where you have to include all the development costs, all your developer salaries, the software that you purchase for like CRM and ERP, all those dollars you put in that bucket. You separate it from all the dollars you spend on hosts and servers and laptops, and you separate it from the network bucket, which is routers and switches that connect all these systems together. Now, who gets the most money? IT dollars. What bucket gets the most money? Applications? I think so. Anybody agree? Everybody agree? Nod or shake your head. Looks. I'm sorry? Hosts? Could be. What company do you work at? No, sorry. I think, and I saw some yeses and so, but anyway, I think it's the applications that get the most, and I think this is how it's normally broken down. But there are outliers. There are different companies that spend differently, but I think for most companies, I recently heard from one of our large banking customers that they had more software developers than you all. Now, that's IT. Let's do the same logical exercise with the security department, the Chief Information Security Officer. You say, all the dollars you spend protecting the IT assets that the business is investing in, how are you protecting? Who gets the most money? I mean, you have the network layer, which includes firewalls. You have the host layer, which is antivirus and patch management. And you have the applications, which is like threat modeling, software architecture, and things. From security perspective, who gets the most money? Network? That was easy. OK, I got that same one. This is how it's normally broken down. So you start lining this up, right? You get this chart. What the business spends the most in is what security spends the least on protecting. I think spending on security is 180 degrees out of phase at the business. I think, and this just is one person's opinion, the biggest line item in non-security spending should match the biggest line item in security spending. It would seem to make logical sense. Now, you might adjust for risk. Maybe what we invest the most in is not what is at the most risk. But I just got done sharing with you that all the attacks and all the vulns are in the web application layer. So that still doesn't make any sense. So it's one thing to do this audience-based exercise. And maybe we were wrong. So I wanted to get some empirical data on the matter. So I got a whole lot of examples. Let me share with you one. This is a survey in 2010 of IT pros and C-level executives from 450 of the Fortune 1000 companies. Here's what the survey said. Nearly 70% of those surveyed said mobile computing is the biggest threat to security today, closely followed by social networks and cloud computing. That is what worries the executives, security executives. Later on in the report, it says 45% said firewalls are their priority security purchase, followed by antivirus, authentication, and anti-malware. Somebody is not seeing the disconnect. At what point does a firewall protect the threats of Facebook? You're right. So this might be a big reason why these attacks continue to happen, because we're spending over here, but the attacks are over there, so we can't possibly get any better. So again, this might be just one survey. So I wanted to get some big numbers. I found an analyst that had some numbers on market sizing, right? So this is the big picture. Market sizing estimates for network security range anywhere from $5 to $8 billion annually. And the aggregate application security market is about 440 million, so less than 10% of the size. So everything starts to line up. I think our spending priorities are completely backwards. And unless that changes, we're going to continue to have these problems. Fortunately, the same analyst report said the application security market will grow 23% year over year, which I find is pretty cool. So that provides us some. That presents with us some rather difficult choices. We can Now where does that leave us? At least the security departments. We could reallocate resources away from firewalls, intrusion detection systems, and antivirus towards application security matters. Developer training, secure architecture design, all sorts of things. We have no shortage of software security things we could be doing. But to try to displace an entrenched market, I mean, imagine having to spend less on firewalls and more on application security. I mean, it's a hard choice. These are entrenched markets, and it's like, imagine not doing these things. And also, as we mentioned, I think Katie mentioned on the compliance side, right? Compliance a lot of times forces these behaviors. You can't not spend less on these things because they're entrenched forever. Compliance prevents us from making ourselves more secure. So I'm even more hostile against compliance than anybody because compliance tends to try to enforce controls rather than outcomes. And it's backwards. The second option is you can justify brand new application security spending. Spend more money on security, but imagine again from the CISO's perspective and the security department's perspective, from your perspective, trying to ask for more money on security after you've already spent a mountain, especially in a down economy. So again, this is an equally tough road, maybe even more so. Of course, we do have the third choice. You can keep the status quo, and breaches continue and get worse, which seems to be what our choice is so far. But we also always got to remind ourselves, I have to remind myself, because I get so deeply engrossed in this stuff, is that security is optional, but then again, so is survival. Thank you.